Hello, everyone. Just going to give one more minute. Thank you for taking the time to join us. I just want to do a quick sound check. Let me know if you guys hear me. Give me a thumbs up or comment in the chat section. Sound check. You guys hear me? Great. Okay, I see some thumbs up. Appreciate it. My name is Matthew Daniel. I am product manager for the Avoidable platform at Fortress Power. And I'm excited to introduce the new inverter, hybrid inverter in our Avoidable platform called the Solo 6.5 inverter. We really wanted to reach out more to people who want to reach energy resilience within their own property. Particularly people who want to go off grid or they just want to offset some loads on their property, right? That we brought a indoor rated inverter at a very low cost, but very, very powerful, right? So we're going to start with the presentation. But there we go. Great. All right. So off the bat, the first thing that I want to introduce of this inverter is that it's a 6.5 true output inverter, and not just when it's at 120, 240 split phase configuration, but at also a 120 single phase configuration. Let me say that again. It is also a 6.5 kilowatt inverter at a 120 volt single phase configuration. That means from line to neutral. Now we're going to go some of the installation processes on how to achieve that, because there is a special process, right? Installation connection to achieve that. But nonetheless, it can do that, right? There are a lot of regions and jurisdictions that are, moving out of using a split phase devices. You have stoves or ovens that are gas, right? And they don't need that 240. They're not electric stoves, so they don't need that 240 input. Dryers are using gas technology as well to heat up, and no longer need a 240 input. So taking those aside, you can essentially wire your property at 120 volts, right? So from the output of the inverter would wire 120 into your panel, assuming you don't have double pole circuits, okay? Moving into the PV side, the inverter comes equipped with two MPPTs, 5 kilowatts each, where MPPT has the capacity of charging the battery at 140 amps, okay? And it is very flexible in terms of the voltage. It does allow 125 volts to 550 volts DC, and 550 volts DC would be the max input voltage, saying open circuit voltage, right? It uses a maximum of 18 amps, and it is the maximum, right? Can go over that, 18 amps usable, okay? The battery can charge and discharge continuously 6.5 kilowatts, and hence why the inverter has that rating of 6.5 kilowatts, where that 4 kW can be charged using AC power, okay? Maximum of 4 kW using AC power. That's either grid or generator. It is applicable to use with 15 cells and 60 cells batteries. And the reason why I say that is because we do have a 15-cell battery called the eForce, which could be well suited for this type of application. But we highly recommend using the 16-cell eBoost, just because of it is a more cost-effective solution when paired with this inverter, right? For the grid, you have a 9.6 kilowatt pass-through. Okay, so pass-through from grid input to load. And then this inverter with that can do 120 to 240 single phase, or 120 single phase, 120, 240 split phase. And then it can also do 120, 208, having a minimum of 3 inverters, okay? Where we can parallel up to 6 inverters of the Solo 6.5. That's the maximum scalability. Load output, as I mentioned before, rated at 6.5 kilowatts with a peak surge of 13 kW for 5 seconds. And the generator also has a pass-through, same as the grid, of 9.6, where it can use 4 kW to charge your batteries and also distribute to loads and power your loads. There we go. Okay. So as I mentioned before, it is an indoor inverter, IP20, scalable to 6 units with a transfer switch of 10 milliseconds, which is pretty impressive, pretty seamless. It has an automatic neutral ground bond. So what that means is utilities, usually when you do a ground bond, you would do it at the meter or at the main panel, basically where grid feeds in. But if you were to do this in an off-grid situation, potentially where the grid is not accessible, then the inverter has the capability of bonding at the source, which in this case would be the inverter. And that would just be on the LCD parameter settings, which we'll go over very soon. It comes equipped with a 5-year warranty, product warranty with Fortress Power, and it includes all your required breakers. It requires your PV disconnect, right, to shut off or shut down the PV input going into the inverter. It comes with a power switch button on the right side of the inverter. It comes with 3 50 amp AC breakers, so that would be breaking the grid, gen, and load, and then a 200 amp battery breaker, okay, just right here. This is the 3 50 amp AC breakers, 200 amp breaker, your PV input right here, 2 MPPTs, positive and negative on PV1, negative and positive on PV2, okay? And then the reason why I say that is because I know they're inverted on MPPT2, so just keep in mind when you're installing MPPT2 or PV1 that you don't get a positive, negative, positive, negative. It should be positive, negative, negative, positive. Okay, you have your communication port on the bottom, parallel B and parallel A. So when you go from inverter to inverter, you're going to start from parallel A with an RJ45 cable that's included within the inverter, and then connect to the other inverter landing on parallel B. And you have your other RJ45 ports, which would be your CT port, which is not required to use with the system unless you're doing zero net export, which basically would be offsetting. You basically tie the inverter with a breaker at the main panel, feeding the grid input of the inverter, and then the load output of the inverter feeds essential loads. So if you want to quantify your entire home consumption, then you need a CT to then bring it into the grid feed into your main panel, right? So that would be in between your meter and your main panel. Essentially, typically it's after your main breaker, or your main panel breaker, sorry. Then you have your Wi-Fi CT, which in this port you will integrate your Wi-Fi dongle. that is included with the system to connect it to your home router and then sync the system over the internet for monitoring purposes. And then you have the BMS port, which is RS-485 and CAN compatible. In the case of Fortress Power, we're all going to be using CAN communication, whether that's Evo Max, eForce, eBoost, eFlex Max, and any other Fortress Power 48-volt product will use CAN communication. Then you have your dry contact ports, which will allow to enable or disable your AP smart transmitter, which is not included, but this would be the area where to connect it. Then that will also allow you to enable or disable your generator. So when your generator has a 2-wire start capability, then the 2-wire would be plugged into pins 5 and 7, I believe, which we're going to get to. And then you have your neutral connections port here, and then your ground connection bar below that. This would be your battery negative and positive ports. So there's where you land your positive and negative directly from your primary battery. And then, like I said, your disconnects. On top, you have the knockout holes, which be perfectly well seated in top of wireway. Or you could hang the inverter on the wall as well, and then feed the AC on the left side and the DC on the right side. The knockout hole on the side is a 1.5-inch knockout hole. So just take that in consideration when installing this system. Up next, we have the inverter's interface, which is the LCD interface. Okay, you have an LCD on the front of the inverter. Then you have your toggle buttons. You have up, down. You have set, which basically enables the user to go into the settings mode of the inverter. And then you have enter, right? When you're selecting, you select enter to confirm the settings that you want. Then you have the 3 indicators, AC, IMV, which is it's basically inverting, and that should always be green, assuming everything is in normal operation, or that if is in bypass mode, coming from grid to load as well. Then you have charge, which is in yellow, assuming that it is charging. You would see it flashing. When it finishes charging the batteries, then you would see it on a solid status. And then fault, if we have levels of fault. Level 1, which is the less severe, right? I'm sorry, the more severe. That would indicate fault. It would always be on. Flashing would be level 2, which would be less severe, and then off, level 3 or level 4. Okay. Simple tools that you need it. You don't need anything. It's a very simple device to install, very easy to maneuver. It weighs about only 50 pounds, so it's essentially a one-man job, but we always recommend having a second person to install your system just for better safety. But I personally carry this inverter myself. It's very, very easy to handle. Simple electrician tools, cable lock crimper, wire stripper, electrical tape, and a multimeter. Nothing more than that. Personal protective equipment, have your PPE equipment, boots, glasses, gloves, right? And then the usable equipment that you should always bring with you: socket wrench set, drill and a drill bit set, a dolly and a hand truck, and that's just more for your batteries, and then a screwdriver set. That's pretty much it. All right. So like I said before, this inverter pairs perfectly with the eFlex Max 5.4 kilowatt hours. We do recommend having a minimum 2 since the battery charge is 140 and the maximum of the eFlex Max amps charging and discharging is 100 amps continuous. So 2 of those would be perfect with the Solo 6.5, and that should cover most of your single home, 1-bedroom home, maybe apartment or small home. We've seen it before that a 6.5 kilowatt inverter and an eFlex Max are more than suitable to last the night, assuming that the devices connected in your property are gas appliances, right? Then you have the eBoost, which is the 16 kilowatt hour battery that we just came out, that has a continuous 250 amp discharge and 180 amp charge continuous, right? You can essentially not sit the inverter on top of the E-way, but you can mount it a little bit upwards and then run a flexible conduit from the top of the E-way, which is this part, right? The top of this E-way, for those who don't know, has a knockout accessibility where you can run a conduit and land it on the bottom of the solo inverter. Or you can put the solo inverter on the side of the E-way and then use one of the 1.5-inch knockout holes from the eBoost, and you can use flexible conduit like liquid tight and then run it to the side of the Solo 6.5. And yeah, eBoost for sure would be used for those properties who are using electrical appliances. I mean, both of these batteries can be used for electrical appliances. The thing that would be dependent here is the capacity, right? You know, how much do you want your batteries to last running these types of double pole loads, right? And that would just, you can go use Fortress Power's sizing tool to give you that number of batteries that you need for, you know, resiliency for 1 day, 2 days, or half a day. All right. Here next is, for those of you who don't know, we do have an outdoor enclosure option. If you want to install this inverter, the Solo 6.5 outdoors, it is an indoor inverter, and we do have an outdoor inverter, which is the NV Duo 21, which is a 12K output inverter. And we have the 10K and 8K, which are all outdoor rated NEMA 4X IP65. But if you wanted to go with a smaller rated inverter and install it outdoors, then the Flex Tower would definitely be an optimal solution. You can fit the 6.5 on the top compartment of the Flex Tower, and then the batteries, in this case, they host, the Flex Tower hosts up to 4 eFlex Maxes, right? Where you don't need to provide any cabling from the battery to a included bus bar. You do need to include a cable, a 2-watt cable that goes from the bus bar to the inverter. Okay, the Flex Tower already comes also included with integrated fans for, you know, hot climate weather. It will self-trigger, so it is already come programmed to, I believe, initiate after 90 degrees Fahrenheit. And it is IP54, so it's outdoor rated, where the bottom part, which is the battery chamber, as I mentioned, is vented. Okay. For those of you who have any questions, feel free to just put any questions in the chat. I can happily answer those as I go and make it a little bit more dynamic. But yeah, don't feel free to just ask any questions that come up as I go. Okay. All right, next is the unboxing. Basically, these are the components that you can expect when you're opening the box of the Solo 6.5. First off is the Solo 6.5 inverter. Again, weighs 50 pounds. Then you have the wall mounting bracket, which already has the 16-inch dimension. So all you would really need is a stud finder to make sure you mark where your studs are, and then you can place the wall mounting bracket where the holes will land 16 inches apart from each stud. And you have your installation user manual guide. You have the dongle that comes with it, an inverter to inverter communication cable, and that's going to be 2. But it can also be used as an inverter battery communication cable as well. A CT, basically your current transformer sensor, that will only be used when you are doing zero net export, essentially, right? In a whole home backup scenario, you don't need to use the CTs. They are rated at 300 amps, 150 milliamp output, which will give you a 2,000 turn, 1/2000 ratio. That's already pre-programmed on the inverter, but this is just extra information. It comes already with a 2-watt log terminals, so all you need to bring is really your crimper, rated for 2 watt, your mounting screws, expansion screws, and then Phillips screw and a black screw and some black screws. This is just basically to lock the inverter in place when you're installing the wall mounting bracket. And then your battery screw terminals, which are already connected into the battery port. Okay, installation. All right. One thing we are going to require, and that's just more for better heat dissipation, will be that each inverter is spaced 8 inches apart, assuming you're installing multiple of them. Again, reminder that you can do up to 6, but inverter to inverter spacing should be 8 inches. Inverter to wall spacing should also be 8 inches, and inverter to floor should be 8 inches, although, you know, it's not, that's more for heat dissipation. We recommend installing the inverter at an eye-seeing level for sure, and a reachable level. The one thing we do want to consider when installing these is that the PV disconnect, which would be this guy right here, is not over 6.7 feet per NEC code, right? You want that to be reachable in order to be, you know, disconnected. Do not install it, you know, at an angle, right? Always keep it flat against the wall, not upside down, not on the side or anything like that. Okay. All right. First step is going to be, you're going to take the wall mounting bracket, as I mentioned before, 16 inches from side to side. You're going to place it against the wall, and you're going to have a leveler mark the holes of each side, drill the holes, and then fit, whether it's going to be a wood screw, an expansion screw, fit the wall mounting bracket, and then install the wall mounting bracket on top. Next is going to be the PV connection. As I mentioned before, we have two MPPTs where we want to make sure that the strings that are being connected, each module is facing the same direction. And that if you are going to include rapid shutdown, that each module, if you're using a double rapid shutdown receiver, then you can put two modules into that receiver. If you're using a single module receiver, then you can install it each module individually. Ground the modules, right? For ground mount installations, you don't need to install rapid shutdown. But continuing, you would do that single string into MPPT1, assuming this string assuming this string, it would be onto MPPT2, and then this string onto MPPT1. Remember, positive and negative, negative and positive, where the ground should land on a grounding electrode rod and not directly into the inverter. You want that if something were to happen, you know, it goes into your grounding run first, right, per NEC code. Okay, next up, you have, if you wanted to add rapid shutdown to your system, you would use pin 1 and 2, okay? And you would put the external AP Smart transmitter, and we recommend using AP Smart just because it's a very cost-effective solution. You can go with Tigo, as long as if you use Tigo or AP Smart or a mix of between, which you actually can, you do that as long as there's both SunSpec compliant. The one thing that if you use Tigo, the source going to it, or it demands about 1 amp. There are other lower consumption Tigos, but essentially this inverter only outputs 500 milliamps. And that's why we always recommend AP Smart, because AP Smart, that's what they require, 500 milliamps. So, so putting the rapid shutdown, you would put a rapid shutdown button, right? We would say a normally close button, and you would take the cable from pin 1, connect it to the normally closed button, and then from the other side of the rapid shutdown button, you would go into your external AP Smart transmitter on the negative, and then return on the positive to number 2. If you're doing rapid shutdown at a parallel in a parallel setting, then what I would recommend is, what we recommend is, there is these 3-to-1 lever wire connectors, and you can get these in Amazon pretty cheap. I think they're about $10, and they include about 10 of those. You'd be only using 2 essentially. But you're basically putting each rapid shutdown in parallel with the inverter, right? So from pin number 1, negative, you're going to land on the negative of the AP Smart transmitter. And then from the positive, you're going to put it in parallel on the rapid shutdown button. Now, the second option would be to actually get a rapid shutdown button that has multiple connection points. I think there are 3 poles, 4 poles, 5 poles, or 6 poles buttons where you can do this. Now they're a little bit more expensive, and that's why I recommend it using the 3-to-1 lever wire connector, right? So you have 3 connection points here on the positive of each rapid AP Smart transmitter, and they will land on this lever connector. And then from there, it would go one cable into your rapid shutdown button. And then from there, you would go one cable landing into the one-sided of the lever connector. And then from there, split 3 ways into the positive port of the contacts. And so this will allow you so that when you press the button, everything goes into rapid shutdown mode immediately. Now the rapid shutdown mode is only at a PV level rated for now. For now, it is only rated at PV level. It's not going to shut down loads or battery. Okay, I know there are some jurisdictions that are mandating a whole system rapid shutdown level. This inverter is not able to do it yet, but we are working towards that. Hopefully we'll have a solution by the beginning of next year. Okay. The battery connection. Okay, this is a high-level overview of how your battery connection would be. Now, we would go into a typical battery to bus bar to inverter connection. There are some inverters, like the MV inverter from Fortress Power, that has the do not share battery function, but that is not applicable with the Solo 6.5. Solo 6.5, each inverter has to land on a bus bar, and from that bus bar lands into each battery individually. And so this is coming straight from the manual, but I wanted to sort of go over the philosophy and the explanation of the overview. Each inverter would use 2-aught cable landing into the bus bars, right? And then you would have the communication cable going from the primary battery, whether that's eFlex Max or eForce or eBoost, from the primary battery all the way to primary inverter. And then from the primary inverter, you have the communication cable going from parallel A to parallel B. Alternatively, or optionally, you can also integrate the Guardian, which if you purchase the Guardian and a Guardian monitoring kit, it will come with a splitter where basically allows the Guardian to tap into the eFlex Max. And that's just really only needed for eFlex Max. It's that monitoring kit is not required for the eForce or the eBoost. Okay, you just buy the Guardian, and the Guardian plugs directly into the E-way of the eBoost or the E-way of the eForce. Okay, so like I said before, the inverter has the capability of being connected either 120 volts or 240 volts, or 120 single phase or 120 240 split phase, right? And this is the way that you would do it, right? Assuming that you're using an installation where a breaker from the main panel feeds the inverter, then you would include the CT, right? And if you're using 120 single phase, then you're only going to use CT1 of the pair of CTs. You usually have CT1, CT2, CT1 for line 1, CT2 for line 2. And in this case, you would only use CT1 if you're only feeding the inverter at a 120 single phase, right? And so the thing that we would recommend is always using either a Polaris plug or something equivalent, or the Polaris dual-sided connection, number 6 gauge. And so the feeding would feed that Polaris plug, and then from there you would split 2 ways into the grid breaker. And that's how you can achieve the 6.5 kilowatts on this inverter, is that it's using both lines, even though it would be programmed to work at 120. it would still output 6.5 kilowatts. Now, if you were going with that option, right, using a 120 feed and a 120 volt output, then you would have to go into the LCD under parameter 68 and set that to 0, right? 0 for single phase mode. And then alternatively, for the 120 to 40 single split phase, then you would use CT1 and CT2, right? And then just feed directly into the inverter without any Polaris plugs or anything like that, right? And again, reminder, you only need to use the CTs when you are when you have essential loads, essential loads. In a whole home backup scenario, you don't need the CTs. Okay, now whole home or essential loads, right? As the thing that we've been talking about. You have essentially on a whole home scenario, you want the inverter to back up the entire property, whether that's a backup of pass-through or a true whole home backup, where you basically feed the inverter through the main breaker, or the main breaker would feed the grid input of the inverter, right? Apologize. Where you would have to keep in consideration that you would have to here do a ground neutral ground bond, right, at that main panel. Or you have the main panel, right, of your property, and then the main panel with a double pole 50 amp breaker would feed the grid input of the inverter. So those are the two types of ways you can feed the inverter, right? And then the load output of the inverter would tie into traditional main panel. Main panels standardly for residential come 2 poles, where if you were doing a 120 volt single phase, then you can land each cable into line 1 and line 2 of that load panel, right? Where if you measure with your multimeter, you should measure 0 volts if you measure from line 1 to line 2, essentially, and then 120 volts from line 1 to neutral, right? A standard typical residential application, then you would do 120 volt single split phase, and you would really do that if your property is using 2 pole devices, as I mentioned before. So here, here we can see single pole breakers. Here we see 2 pole breakers, right? For typical electric devices. Then you have your generator connection. Your generator connection, we do recommend for the generator to be a sort of automatic, one of those push buttons generator, because then you can tap in there to then run the dry contacts from the inverter from pin 5 to 7 to that 2-wire starter, or tapping into the push button of those generators. Typical generators now are inverter generators that have a push button, and you can sort of put that button in series so that when this closes, then it engages the generator. And so if you have a 240 volt generator, then you would land 240 line 1 and line 2 on the generator breaker. Now, it is very important that if you're running the application at 120 single phase and you want to tie in a generator, then the generator also has to be 120 single phase. You can't have a 240 generator and running the inverter at 120 volt load output, right? It has to be both. Generator has to be 120, inverter has to be 120. Generator is 120 to 40, then inverter has to be 120 to 40, right? And then you would use the settings, which would be setting 61 and setting 62. Setting 61 would essentially be at the SOC that you set it, it will trigger the generator to start, assuming you don't have grid. It will trigger the generator to start and charge the batteries while simultaneously supplying to the loads. And then it will charge all the way to parameter 62, which would be the SOC at which point the generator would shut off when the generator finishes charging the battery. So if you set it at 100%, it's going to start at 30% and charge to 100% or 99%, sorry. Then you have a way of paralleling the inverters. The most important thing is really parallel the communication ports, parallel A from B. And then after that, you're going to select the parallel mode, right? The parallel mode is going to be number 31, and you're going to select PAL to then, that's going to enable your parallel operation. And then number 38, which you're going to assign which is the output voltage that you want. So this inverter can do 100, 105, 110, 120, and 127 as well. But by default, it will come to 120 volt line to neutral. The commissioning process. Commissioning, if you're using the eBoost, using any battery really, you're going to turn the disconnects or the breakers on first. That's the first thing you're ever going to do. Disconnects first, which in the case of the eBoost, primary, secondary, and last secondary, you're going to flip the disconnect on. Unlike the eForce, you only have to do that with the primary. In the eBoost, you have to do them with all. And then after that, you're also going to flip on the breaker on the battery breaker at the inverter, right? So all DC breakers on and all disconnects. DC. Then you're going to turn on the battery, and in the eBoost case, you're gonna press and hold it for 2 seconds. It's gonna boot up, and if you have multiple batteries in parallel, that's gonna boot up the other batteries in sequence. And then after that, you're gonna make sure that the inverter protocol is selected correctly on the eBoost. By default, this is gonna come compatible with the solo inverter and NV inverter, but I always put this process just to make sure, that if in the process you tapped it and changed something, you can always resort back to these instructions. So it would be inverter protocol. You're going to hold the button for 5 seconds, and then you're going to release it. And then the frames of the battery are going to blink, right? They're going to blink and let you know which protocol you're at. You're going to see this, right, the outer frames, and then you're going to see the SOC bar. The SOC bar has to always be at the 25% mark, which is the bottom bar, okay? So this is 25, 50, 75, 95, and 100. So typically, or you should be able to see it at the first bar. Oops. Commissioning the eFlex Max, essentially the same thing. Flip on the DC breakers, the battery breaker, and the battery breaker on the inverter, and then you're gonna press the push button on the primary battery, and then that's gonna light up the other batteries. And then you're going to select the protocol the same way that you do with the eBoost. Hold 5 seconds, and in this case, the eFlex Max lights up green, but you should see the same configuration. Then you're gonna press the push button on the right of the inverter. Okay, and that's gonna boot up the inverter. And then you're going to enable the PV switch on the side of the inverter. After that, you can begin sort of programming, although, again, this is just more for training purposes, and I'm letting you know what they mean. But all of these are, they come by default. The eBoost comes by default SBU, which is self-consumption mode. It's basically going to prioritize the PV to your loads and battery charging. And then when your battery is not sufficient, when SOC depletes, it's going to resort to either generator or resort or to the grid, right? Whichever is available. If grid is available, then the generator is not going to turn on. If grid is not available, then the generator will turn on. So, and that's going to be on 61, right? Parameter 61, as I mentioned. So going to the battery settings, by default, L14, L15, and L16 will be the default, and it's going to resort based on what type of cell battery you have. If you have a 15-cell battery like the eForce, I see my guy Maverick Brown there. I know he has one eForce. You know, using the solo inverter, that will resort into L15. If you're using the eBoost, then that will resort into L16. But if you have no battery, then you can select no battery, which is NOB. I apologize that it's not visible, but there is a NOB section. You don't have to program any of the voltage settings. You're going to be using SOC, in which here, these are the defaults. The battery cutoff will be set at 20%. Battery setting charge cutoff is at 99%. Well, it's greater than 99%. So SOC switching from grid or generator is going to be set at 30%. And then SOC setting for switching to inverter output, so when the battery charges up to whatever you state here, then it's going to go back to inverting mode. Any questions? Cool. I wanna leave a couple minutes for questions. That will be all for the presentation. But if you like any other more detailed information, always go to fortresspower.com. Under the product section, we do have our installation manual, our data sheets. The installation manual does go more in depth of all the settings that you can have. It's not only for self-consumption, but also backup mode, which we typically see this inverter going into a self-consumption off-grid mode, and that's why we set it at default. It has many other applications, including also how to connect it three-phase if you're doing three-phase, more parallel instructions, although I think I covered more here, but it also lets you know what's the bus bar recommendation. So the manual is designed that if you see something like this, I'm going to go back. You will see in the manual things like this, right? When you see that magnifying glass, it's basically us saying, hey, how it's worded here, you can literally type it that way, and you can source these parts from either a local distributor or national distributor or even Amazon, right? Like order them today, same day shipping, and you can get these simple devices, right? And it is made for that. So every time you see that, you just really have to type, in this case, Polaris 3-port dual-sided connector for 3-gauge connection, and it will pop up. So we wanted to make it as easy as possible, plug and play. Again, everything comes programmed for you, but if you would like any other information, please visit us at fortresspower.com. And you can also submit a ticket under the support section, and we'll get to you hopefully in less than 24 hours. All right. Thank you all. Thank you. Thank you for joining us. I will end the presentation, and
Matthew, there's one question in the chat.
Okay.
If you go over to the Q&A.
Oh, I see. Is the inverter rated for mobile application vibration? Also, which battery can handle road trips? Maverick, no. The inverter itself is not rated for mobile applications. I will say, though, that the one that is the eFlex Max, and believe it or not, the eForce, and more the eForce because it is a contactor base battery, so it's better for those types of applications. But if you need something smaller, eFlex Max is highly recommendable as well. If you need Maverick, I can also send you some vibration tests on these batteries to let you give you a guide on how they perform. Cool. All right. Thank you all. Thank you for joining us. Have a good day.